Welcome to the Advanced Hobby Lab. Today I will be continuing the work on my SpotMicro build. I will be focusing on adding a power switch and an LCD display. I have my current SpotMicro build here set up. The main problem that I'm currently facing with it is the power connector. As it stands right now, the only way that I can turn this thing on or off is by literally unplugging the battery. This means I basically leave the top of the chassis open all the time. I would like to be able to close this up, but I can't do that until I have a power switch on the outside of the chassis. I 3D printed this new rear module. It has two cutouts already for it. One should fit a switch, and the other one should fit the LCD display. The challenge will be how to mount this into the rear module. These switches have these little tabs on either side of it that will actually grip into the part and hold it in place. The LCD display, on the other hand, has mounting holes already built into it. Now this is really convenient for a lot of parts. Unfortunately, the part I found for the rear module does not have any mounting holes, so I don't know exactly how I'm going to end up mounting this. We'll find out together. This is the power regulator that I built in a previous video. It takes the 7.4 volts in from the battery and it outputs 5 volts necessary for the Raspberry Pi. I've also soldered on some extra leads in parallel to the battery to plug directly into the servos. This allows me to power the servos directly with 7.4 volts. So the switch I'm going to be using is an illuminated switch. It has 3 prongs on the back. It unfortunately doesn't seem to have any markings to tell me which one's which, but I've already taken a multimeter to it and I found out that these first 2 here are for closing the loop. So that's voltage in, voltage out, and this third one here is ground. So in order to get the LED to work in the switch, I need to connect the ground. So that's not really needed, but might be nice to have. I need to focus on getting these 2 connected in line with the power regulator. In order to connect the switch, I need to desolder this wire from the board and then add some extra wires to connect in the switch. I got these quick disconnect terminals to attach to the end of the wires for connecting onto the prongs of the switch. Let's get started. So here's the finished power regulator. As you can see, some of the soldering joints may be a little bit ugly, but I've confirmed that they all work, so we're going to leave those for now. We also have amassed quite a few extra cables. This is getting to be a little bit cumbersome, but we're going to just stuff it in the chassis and we should be fine. Our next challenge is how do we plug the LED module into the Raspberry Pi? We're currently using the 16-channel PWM servo hat from Adafruit. It's currently plugged into the Raspberry Pi and taking up all the GPIO headers. Fortunately, it comes with this prototyping area, and this is what we're going to use in order to... Now this is... Our next challenge is how do we attach the LED module into the how do we plug the LED module into the Raspberry Pi? We're currently using the 16-channel PWM servo hat from Adafruit, and it's currently taking up all the GPIO headers. Now this is the board I've been using. It's a little bit worse for wear, as you can see, but it does work. This board comes with a prototyping area along with breakouts for 5 volts, 3.3 volts, ground, and various GPIO headers. I've already added a terminal block for powering the Raspberry Pi. I connect it to the 5 volt power as well as the ground on the back side of the board. What I plan to do for adding the LED module is to use this simple little 4-pin header and solder it right there on the edge. I can then route cables to the 5 volts, the ground, as well as SCA and SCL on the GPIO headers. So the pins are soldered on. You can see I soldered the power and ground on the top of the board, and I soldered the data lines across the bottom of the board. This looks a little bit sloppy. Getting the cables with the exact right length is a little bit tricky, but this does work. I have tested it with a multimeter. I know all the loops are closed, so we're ready to move on. Now it's time to try to mount the LCD module inside the rear module. So as stated before, there are no mounting holes. So what I think I'm going to do is I'm going to try to use one of these heat press inserts. There's nothing to press the insert into, so I think I'm just going to glue it. I'm going to screw a nut onto this M3 8mm screw. I'm going to insert it through the module and screw the insert onto the other side. This keeps the screw a few millimeters away from the edge of the insert. Now I'm going to do the same thing on the other four corners. So these offsets should now keep the module at the right distance. Now we can start putting it all together. Now that we got this all built, we can just flip the switch and turn it on. If you give it a few seconds, it'll tell us it's ready. If you like this video, be sure to give me a like. If you want to see future content on my SpotMicro build, please be sure to subscribe, and thanks for watching.